Okay, welcome to the Virtual Production Studio Lab. Today I'm going to talk about rapid environment creation for virtual production. And I'm Andrea Nordwall, a lecturer in media technology at the Peking Institute of Technology. So, in virtual production you use, in virtual production you use 3D environments for extending sets in film industry, and this heavily 3D based workflow is dependent on the construction of 3D environments, which, while the cost can be lower than for physical sets, it's still something that would drain production and be costly and time consuming. And this is especially true for highly realistic and large-scale environments. You need teams of competent 3D artists modeling and creating these environments, which can be time-consuming. And while this is of course a concern in the creative industry, this is also applicable for other industries that work with virtual production. So what can be done to reduce costs? What kind of approaches are possible? The idea is to give you an outline of different possibilities on how to reduce these costs and various approaches that could be explored in the future in this environment. And one approach that is widely used currently is procedural generation of environments. And in procedural content generation, you often work with preset libraries of assets, of 3D assets, that are distributed in an environment to create a full 3D immersive experience. And here we see an example with a landscape, which is the gray grid, and a set of points where trees are being distributed. And if you make complex enough rules and conditional rules, you can construct complex environments like forests, cities, etc. by combining preset, pre-scanned or pre-made assets. And this approach is highly used in the computer game industry, especially to create open world games. You often have this approach to create entire worlds full of assets. So instead of placing individual assets, we create rule sets for where assets are placed and how they are combined, and condition that. Another level of this is of course to generate landscapes. These assets are normally placed on a surface, a landscape, and this can of course also be generated with procedural conditioning like asset placement. So here we see an example of a generated landscape. We see the node system that generates landscape, and in this case the landscape uses various natural processes, arbitrations or simulations of natural processes to enhance the look of the landscape. For instance, erosion and sediment is introduced to the landscape to give it a sense of realism. If you really want realism, you should base it, of course, on real data. And here we see an example where I've imported satellite data and based a landscape on that. You see the node system that enhances this landscape. A problem with scan data is resolution. If you have high enough resolution, it's no problem. But if you have low resolution, you sometimes have to simulate natural processes to increase fidelity or perceived fidelity. So in this case, we see the landmark of Ale stenar, which is a landmark in southern Sweden, a very distinct landscape shape. And you get this, but I've enhanced it with natural processes to hide low resolution and give a viable example of how this place would look in high definition, even though we don't have the data. But of course, ideally we have high resolution scans. And this is something that could be interesting for virtual production if you want to recreate a very specific place with a very specific look. and don't want to manually construct this entire landscape. Another approach other than procedural generation, which is about conditioning with rules, is asset generation. And this group of approaches is based on the idea that we have a 3D environment and we could accelerate the construction of this environment by generating individual assets in this environment to populate the environment. And this is of course an alternative to asset libraries, which there are extensive asset libraries today that are photorealistic, but the content in them are of course limited. You're limited to what you can do. Then asset generation can be an alternative. So I will show some examples of how that can be done. One example of asset generation is generating materials for 3D meshes for use in 3D environments. So here we see an example where the surface, the material of this digitally created blanket has been created with a diffusion model. And this can be a way to create custom or specific materials that otherwise would take time to create. Of course, a lot of materials are available in asset libraries, but for specific cases this can be interesting. And in particular, if you want to have materials that need a lot of materials that are custom for specific assets. And one such example is if you need wear and tear of assets. They should look used, they should look torn, etc. Then a generative approach can be successful to give look to individual assets at scale. Another possibility is to use a multi-view diffusion model to generate meshes. A multi-view model is an image generator model based on diffusion architecture that is trained to generate images of an object from different perspectives. And you can use these different perspectives to calculate how this object would look in 3 dimensions, resulting in a mesh with a texture. So here we see 3 examples of that. And as you can see, the quality currently isn't that great, and that limits how useful this approach is. But for virtual production, for creative production, and for other use cases, this sometimes might be enough. Especially for use for filler objects that need to be unique, and you need like a mass of them. Such as if you want to make like a toy box with lots of many different strange toys, maybe you could generate them, and this quality is not a problem. Or you need silhouettes of a crowd of people standing still in the distance, and you need them to be unique. Maybe you could generate them as an alternative. So this is one way to, and hopefully we will see better improvements in quality in the future. Another approach for virtual production is to generate assets that are flat. And we often talk about cards or plates in the film industry. A card is a still image, a plate is a moving image, but they are flat. And this can be generated and used in areas of a 3D environment that have low parallax, where you have low movement sideways. So in practice this means objects that are very far away, they will not move very much, even if you move the camera. So distant objects or objects that for other reasons don't move very much. So here we see examples of a diffusion model that can generate objects with an alpha channel, meaning that they are transparent, as you see in the lower third row. And these could be used to populate a 3D environment as an alternative to full 3D objects. And of course, this could also be done to create unique assets where you need many different assets with different looks very quickly. And this type of flat assets for use in low parallax areas of the 3D environment, they could be enhanced with the use of image generators and techniques that generate depth maps. So here we see one example with a depth map generator, Depth Pro from Apple, and a normal generator. And this data can be used to simulate light play and shadows on a flat object so that it seems as if the object has depth and can cast shadows. And you can do this with cards or plates that are photographic, that are generated, or with filmic material that is a sequence of images over time. And this could be useful if you want to make 2D plates or cards look realistic and respond to a lighting environment. So I suggest this as a step 2 of generating 2D plates. And of course this will only work in low parallax, otherwise you will soon be able to tell that this is not 3D. But adding depth and normals would of course enhance the illusion. Another possibility for rapid 3D environment generation operation is to use a diffusion model to project a texture onto a boxed up environment. So here we see an environment with just boxes, and we have a diffusion model that uses the visual structure of that environment to project texture on top of this box out or this very provisional environment. And of course this is much quicker than creating materials for every object in the room, and you can also quickly redo environments. And this can be very useful for simple scenes that do require parallax, but you only want to box it out and make the composition, and then you can project textures on top of it. This has certain limitations, especially if you want to move the vantage point of the camera a lot, because then you will see gaps in this projection. So there are techniques to do projections from different vantage points to fill in the holes as well. I can see this as a workflow for simple scenes. Another possibility for making assets to populate is to generate lighting environments. So here we see a 3D mesh car with materials that reflect light, but the surrounding environment around the car is generated. It's panoramic, and this can be a quick way to create a lighting environment for brush production. That's another alternative. And aside from these procedural approaches that generate individual assets, I could go on and list more examples of that, of course, is attempts to generate environments or reconstruct environments instead of building them. And a quick way to do this is, of course, to generate photorealistic panoramic content. So here we see one example on the top with a generated equirectangular image, and on the bottom how it would look projected, perhaps on this Nordwall. And the advantage of this method is that it's very quick. You could more or less immediately get a new environment, which could be useful for quick iteration. You could of course also use the depth generation I presented before, or normal creation, to enhance these panoramas and add depth to them. So here we see an example from a Nordwall setup where they have a catalog of pre-generated environments. I don't think they look very photorealistic. I would like some improvements here, but it is possible. And in this setup you can do grading of the environment to make it fit to the foreground, because normally you have, of course, a physical foreground in virtual production for creative industry. And here they also have generated depth data, so you have some kind of parallax when you move around the camera, which can, in simpler scenes, give a sense of depth. So this could be useful for simpler scenes that doesn't require full 3D. One method that has been, of course, widely used in film industry, in post-production, etc., is photogrammetry. It is a process where you take a data set of reference images of a location or an object, use those to create a point cloud with common reference points, and then use this point cloud to be able to generate a mesh, and then use projections from reference images onto the mesh to create texture. So here we see the full process. And this is a drone scan I made of the town square of the nearby city Karlshamn here in Blekinge. And I guess this particular model could be used for maybe a shot where you fly or something, also, or for other applications. But photogrammetry has been around for a while, and it means that you can digitize a location and use it for virtual production. And we saw an example of this earlier today in the tech demo in the morning, where I had made a 3D scan of a street here in Karlskrona, which we saw in full projection on the LED wall screen. And in camera it looked very realistic, I would say. So this is certainly a possibility if you want to transport a location to a LED stage. Another similar reconstruction technology that has become very popular during the past year, since it was first published, is 3D Gaussian splatting. And 3D Gaussian splatting is an optimization of neural radiance fields, which is a deep learning based approach where you train a model to predict how a place would look from a specific camera location and camera angle. So it is an image generator that can produce novel view synthesis. And 3D Gaussian splatting is an optimization of that using a conditional point cloud with particles that have position, color, rotation, size, and the point cloud is also dynamic, so it is responding to the position of the camera and can change properties depending on the camera view. And that means that the difference between that and photogrammetry is that you can replicate areas that reflect light, like glass or transparent areas, or sometimes even puddles or seawater that is still. And in this example I've added a weather simulation to a 3D Gaussian splat to create this movie scene. The reference photos for this was taken in broad daylight when it was slightly overcast but still sunny. And for virtual production, for creative production, a limitation has been that because you take these reference photos during daytime, and because these are not normal meshes, these are particles, even though they're dynamic particles, it's hard to integrate them in traditional rendering pipelines. It's hard to get them to interact with lights. But a lot of work is happening here. I'm trying to experiment with it, and something that I wanted to see and managed to do is nighttime rendering. So here we see a 3D Gaussian splat with light interaction from a flashlight running in Unreal Engine in real time. I've also added 3 stationary lights and a weather simulation. And this was of course inspired by a technique from film called day for night, where you film during daytime, hold up a color filter in front of the camera, or do grading post-process to have this look where things are black, but areas of the image that are almost black get blue instead. And to get this to work with splatting, you have to tweak color values back and forth to get a correct rendering. But I think we will see more work in this space. And this is useful for film industry because it means that you can digitize a location during daytime and then change the weather, change the time of day, and have a photorealistic result like this. So I think reconstruction of location is going to be important for virtual production. You could also generate full environments using the same methods. So earlier this spring, a lot of people were talking about video generators and a new generation of video generators called diffusion transformer models. And in particular, I thought a conversation about Sora from OpenAI, and here's some example outputs from this diffusion transformer model. And what we see here is an orbit of a lighthouse that kind of looks realistic. If you look at the forest area behind the lighthouse, it does not look very realistic. But other parts of the image do look reasonable, I think. And you could use output like this from a video generator to do reconstruction as if you had taken photos from a physical location. So normally I would fly a drone around the lighthouse like this and take reference photos, but here instead the reference photos are produced by generative AI by a video generator. So by processing this imagery, you can get a 3D mesh like this. So here you see an example, and I'm not editing this at all, just so that you see the raw output. And of course, this could be used as a background or part of a scene for virtual production. And this means that you get more high fidelity sort of text to mesh for environment pipeline. A variety of this is based on radiance fields. Here we see another example of a generated video. So this is an example video from Sora with a camera moving through a reflective, photorealistic art gallery, I guess it is. This is very similar to the kind of reference photos you would take for doing a reconstruction of a location, and you can process it in similar ways. So here is the same environment, but as a 3D Gaussian splat running in Unreal Engine, and here you see the model. And by doing this means that you have a full text-to-environment pipeline for making photoreal environments. And this could be useful in certain production situations where you want, say, a very generic, quick environment. Suppose we make a scene with two friends having a conversation and we just need some kind of generic but three-dimensional background with a cafe. This is something that could be generated in the pipeline like this. What is of course lacking still is editing capabilities to retain artistic control, but that's something that I foresee will happen in the future, both because editing capabilities of splatting are becoming better, light interactions with 3D objects and rendering pipelines are becoming more integrated, and also structure control for video generation is improving in the same way we saw with structure control for diffusion, still image diffusion generation, where you could control much more finely the output of diffusion generators generating images. So the same thing I anticipate will happen for video generation, and when that happens you have artistic control on how these data sets will look, how the generated video will look, and how the environment will look. And then of course you can also edit the environment, and then you have a very solid pipeline for creating photorealistic environments. So to summarize, I've shown that some strategies for making the process of creating 3D environments to accelerate that. And one way is of course to use set up rules that place predefined content or predefined assets in specific places. And this is called procedural content generation. And this can function as an assistance in creating complex environments and populating complex environments. Another approach is, of course, to generate individual assets. It can be materials, it can be meshes, it can be lighting environments, or two-dimensional cards or plates. And cards and plates can be enhanced with depth information or normals to create the possibility of light interplay and integrating the 3D scene. And I also shown that it is possible to use different scanning strategies for bringing locations to a virtual production set through 3D reconstruction, and that can also enable a rapid turnaround. It can also integrate well with these other strategies. And finally, of course, that AI generation of full photorealistic environments is possible and could be useful for this application. Okay, thank you so much.